I need your bank account to update your address. وهذا نفسه.
The last process of the cost management knowledge area, where I will be discussing the earned value analysis in detail, is controlling the project costs. It's part of the monitoring and controlling process group. Control costs is the process of monitoring the status of the project to update the project costs and managing changes to the cost baseline. So in this process, we will make sure that any change to the cost baseline should be officially approved, and we will monitor the status of the project spending and compare it to the cost baseline. The key benefit of this process is that the cost baseline is maintained throughout the project, and this process is usually performed throughout the project as it is monitoring and controlling process. The inputs, tools, techniques, and outputs are depicted in the figure. The inputs, we will need 3 components of the project management plan. We will need the lessons learned register, the project funding requirements, which is an output of the previous process, the work performance data, and the organizational process assets. The tools and techniques are the expert judgment, data analysis techniques, and the most important one is the earned value analysis. We will have also an important tool, which is to complete performance index and the project management information system. The outputs will be cost forecasts. This is the key output. In addition to work performance information, change requests, updates to the project management plan components, and updates to some of the project documents. The data flow diagram of the control costs process is showing that we will need inputs from the project management plan, from the project documents, and the outputs of the determined budget, direct and managed project work, and the enterprise or the organization are all inputs to the control cost process. The outputs of this process, like the work performance information, will be an input to the monitor and control project work. The change requests should be processed through the perform integrated change control process, in addition to some updates to the project management plan components and the project documents. Now the first input will be the project management plan, and we will need 3 components of this plan, starting with the cost management plan, which describes how we are going to monitor and control the project costs. This was planned ahead in the planning process group while we were developing the cost management plan. So how we are going to monitor the project costs, how we are going to conduct the earned value analysis techniques, all this was documented in the cost management plan. Therefore, it's an important input to this process. The cost baseline, which is the basis for comparison of the actual results to determine if a change or corrective action is necessary. This is also an input to this process. The performance measurement baseline, when using earned value analysis, the performance measurement baseline is compared to the actual results to determine if a change is necessary. So these are the 3 components of the project management plan that will be used as inputs to this process. Some of the project documents, or only actually one project document, will be used as an input to this process, which is the lessons learned register. Lessons learned earlier in the project can be applied to later phases in the project to improve the cost control. The third input will be the project funding requirements. It includes projected expenditures plus any anticipated liabilities throughout the project life cycle. We will need the work performance data. Work performance data is an output of the executing processes, and it contains data on project status, such as which costs have been authorized, incurred, invoiced, and paid. So the work performance data is the raw information that comes from the project site. It represents the actual status of the project, and it will be analyzed as part of this process to develop the work performance information and reports. Input number 5 will be the organizational process assets, and some of these assets that might influence this process includes existing formal and informal cost control related policies, procedures, and guidelines, cost control tools, and monitoring and reporting methods as per the organizational standards. Now the tools and techniques of this process, starting with the expert judgment. Examples of expert judgment during the control costs process includes the variance analysis, earned value analysis, forecasting, and financial analysis. Any individual or a group within your organization who have knowledge or experience in any of these topics can be used as part of the expert judgment technique. The Performance Management Information System, or the PMIS, often used to monitor the 3 earned value management dimensions, which we will cover now: the planned value PV, the earned value EV, and the actual cost AC. You cannot monitor these values without the support of a software or a project management software, which is part of the Project Management Information System. It is used also to display graphical trends and to forecast a range of possible final project results. Data analysis techniques that can be used in this process includes the earned value analysis. Now, the earned value analysis compares the performance measurement baseline to the actual schedule and cost performance. The earned value management integrates the scope baseline with the cost baseline and the schedule baseline to form the performance measurement baseline. So why the earned value analysis is a very powerful technique while we are forecasting the project or we are monitoring the project costs, because it combines the schedule, cost, and scope, and it will give you a holistic view on the performance of these 3 dimensions throughout the project execution. Now, earned value management develops and monitors 3 key dimensions for each work package or for each control account on the work breakdown structure. These 3 dimensions are the planned value, earned value, and actual costs. And these 3 dimensions are very important before we dig deep into this technique. Starting with the planned value can be defined as the authorized budget assigned to scheduled work. It is the authorized budget planned for the work to be accomplished for an activity or work breakdown structure component, not including management reserve. The budget is allocated by phase over the life of the project, but at a given point in time, planned value defines the physical work that should have been accomplished. So the planned value is a value you will obtain from the planning. If we are starting a project in January 2023, and I asked you, as you are the project manager, what you are expecting the value of the physical work that will be completed in your project by August 2023, you will tell me, for example, $5 million US. This is the planned value. The planned value is defined as the value of the physical work that should have been completed at any point of time throughout the project. The total of the PV, or the planned value, is sometimes referred to as the performance measurement baseline. The total planned value for the project is also known as the budget at completion. So the overall planned value for your project is the total budget you are planning to spend on your project. It's a planned value, it's a forecasted value, and it is known as the budget at completion. The second dimension is the actual costs. Actual costs is the realized cost incurred for the work performed on an activity during a specific time period. If the total cost incurred in accomplishing the work that the earned value measured, the AC needs to be or needs to correspond in definition to what was budgeted in the planned value and measured in the earned value. The actual cost will have no upper limit. Whatever is spent to achieve the earned value will be measured. So the actual cost is what you actually spent on your project. So if we are today in January and the project started 3 months ago, and so far we spent like $3 million US on the project, this is the actual cost, what you actually spent on the project as the project manager. So the schedule variance and the cost variance are the formulas I will walk you through to determine the project performance in terms of schedule and cost, and both values are depending on the AC, EV, and planned value. The planned value represents what we planned to accomplish. The actual cost represents what we actually spent on the project up to date. The earned value represents the value of the work which is actually completed on the project. So it's not a planned figure, it is an actual figure. So the planned value, it's a planned figure. From day one, you should have a planned value for your project. The actual cost is an actual figure, and the earned value is an actual figure as well. Earned value is a measure of work performed expressed in terms of the budget authorized for that work. What is the value of the work that is actually completed on the project? It's the budget associated with the authorized work that has been completed. The earned value being measured needs to be related to the performance measurement baseline, and the earned value measured cannot be greater than the authorized planned value budget for a component. So the actual value of a component cannot be more than the planned value. The earned value is also used to calculate the percent complete of a project. Progress measurement criteria should be established for each work breakdown structure component to measure the work in progress. Project managers monitor the earned value both incrementally to determine the current status and cumulatively to determine the long-term performance trends of the project. So if you have like a story in a construction building, one floor should cost you like $200,000, and today the value of the work completed in this floor on this story is $150,000. The $150,000 till today, it's the earned value. The planned value is the $200,000. So the earned value is a figure you will obtain from the work performance data in the project. It is expressed in terms of budget. It is the value of the physical work that is actually completed on the project. Now, again, this figure shows the planned value, the actual start, and the earned value. The earned value equals the actual work accomplished in the project. The actual cost represents what the work actually cost, and the planned value represents the value of the planned work. These are the three key dimensions of the earned value measurements. All the formulas I will be explaining in this lecture are based on these three dimensions. Starting with the variance analysis, it's used in the earned value measurement. In the explanation, cause, impact, and corrective actions for cost, the cost variance equals the earned value minus the actual cost. The schedule variance, SV, equals the earned value minus the planned value. And the variance at completion for the overall project equals the budget at completion minus the estimate at completion. Cost and schedule variances are the most frequently analyzed measurements. Why? Because if I want to know the status of my project performance in terms of schedule or in terms of budget, I just need to calculate the cost variance and the schedule variance. You need to memorize these formulas for the exam. I will provide you with some examples in this lecture, and this topic, the earned value analysis, will be explained in further details again at the end of the course in the focus on math section. For projects not using formal earned value analysis, similar variance analysis can be performed by comparing planned cost against actual cost to identify variances between the cost baseline and the actual project performance. Further analysis can be performed to determine the cause and degree of variance relative to the schedule baseline and any corrective or preventive actions needed. Cost performance measurements are used to assess the magnitude of variation to the original cost baseline. So why we are doing this technique? Why we are calculating the variances? To determine the project performance in terms of budget and schedule. We want to know how our project is doing. If the cost variance or the schedule variance value is negative, it means that our project is behind schedule and over budget. If it's positive, it means we are ahead of schedule and within the project budget. An important aspect of project cost control includes determining the cause and degree of variance relative to the cost baseline and deciding whether corrective or preventive action is required. Why we are doing again this analysis? To determine if there is a big variance in the project, we need to take a corrective action or preventive action to fix out this variance. The percentage range of acceptable variances will tend to reduce as more work is accomplished. Examples of variance analysis includes the schedule variance, which is a measure of schedule performance expressed as the difference between the earned value and the planned value. This is why the formula of the schedule variance is the earned value minus the planned value. It is the amount by which the project is ahead or behind the planned delivery date at any given point in time throughout the project life cycle. If you want to know your project is ahead or behind the planned delivery date, you just need to calculate the schedule variance. It is a measure of schedule performance on a project. It's equal to the earned value minus the planned value. The earned value analysis schedule variance is a useful metric in that it can indicate when a project is falling behind or is ahead of its baseline schedule. It will ultimately equal 0 when the project is completed because all of the planned values will have been earned. So at the end of the project, the schedule variance will be definitely 0. Schedule variance is best used in conjunction with a critical path method, scheduling, and risk management. So there should be a combination of the earned value analysis schedule variance with the critical path method we covered in the schedule management knowledge area and the risk management activities. So the schedule variance, it's the difference between the earned value and the planned value. The cost variance is the difference between the earned value and the actual cost. Equation of the schedule variance, it's earned value minus planned value. The cost variance is the amount of budget deficit or surplus at a given point in time. Are we over budget or within budget? It's expressed as the difference between the earned value and the actual cost. It's a measure of cost performance on a project, and it is equal to the earned value minus the actual cost. The cost variance at the end of the project will be the difference between the budget at completion and the actual amount spent on the project. The cost variance is particularly critical because it indicates the relationship of physical performance to the costs spent. Negative cost variance is often difficult for the project to recover. A negative cost variance means that your project is spending higher than the planned budget. Here is again the chart, the S-curve, and the equation of the cost variance is the earned value. Here is the earned value, the red line, minus the actual cost. A positive cost variance means your project is doing good in terms of budget. A negative cost variance means that you are spending more than the planned budget. Another performance metric is the schedule performance index. It's a measure of the schedule efficiency expressed as the ratio of earned value to the planned value. It measures how efficiently the project team is accomplishing the work. It's sometimes used in conjunction with the cost performance index to forecast the final project completion estimates. Now, if the schedule performance index value is less than 1, it means that less work was completed than what we planned for. It means that we are behind the schedule. If the SPI is greater than 1, it indicates that more work was completed than what was planned. It means we are ahead of schedule. Since the SPI measures all project work, the performance on the critical path also needs to be analyzed to determine whether the project will finish ahead of or behind its planned finish date, and the SPI formula is the earned value divided by the planned value. More than 1 SPI, we are ahead of schedule. Less than 1, it means we are behind the schedule. The other performance index is the cost performance index, which is a measure of the cost efficiency of budgeted resources expressed as the ratio of earned value to the actual cost. So the CPI, or the cost performance index, is the earned value divided by the actual cost. It is considered the most critical earned value analysis metric and measures the cost efficiency for the work completed. If the CPI value is less than 1, it means there is a cost overrun for work completed. If it is more than 1, it means we are within the project budget. And the SPI formula is earned value divided by the actual cost. These 4 formulas for the schedule variance, cost variance, schedule performance index, and cost performance index should be memorized for the exam. Another technique that we can use as part of the control cost process is the trend analysis. Again, it's part of the earned value analysis for doing the forecasts. It examines project performance over time to determine if performance is improving or deteriorating. Graphical analysis techniques are valuable for understanding performance to date and for comparison to future performance goals in the form of budget at completion versus the estimate at completion. So budget at completion is what you planned to spend on the project, overall project, since day one. Estimate at completion is the forecasted value at any point of time throughout the project. Examples of the trend analysis techniques that can be used in this process includes charts and earned value analysis. 3 parameters of planned value, earned value, and actual cost can be monitored and reported on both a period by period basis and on a cumulative basis. The figure below uses the S-curve to display the earned value data for a project that is performing over budget and behind the schedule. Now, from this figure, how I can know that the project is performing over budget and behind the schedule? We have the figures here. Here is the data date, okay? Now, here is the earned value, here is the planned value, and here is the actual cost. Here is the cumulative cost. Now, the formula, for example, of the cost variance is the earned value minus the actual cost. Here is the earned value, and here is the actual cost. Earned value minus actual cost will give you a negative result. as the earned value is less than the actual cost, and that means that the project is over budget. Now for the schedule variance, it's the earned value minus the planned value, and again the earned value is less than the planned value, and the difference will give you a negative result, and it means that the project is behind schedule. The second trend analysis technique will be the forecasting. As the project is progressing, the project team may develop a forecast for the estimate at completion that may differ from the budget at completion based on the project current performance. So if you are planning from day one for your project to spend like $2 million US, okay, and the project is 12 months in duration. After 6 months of the project, there are a lot of changes and there are some variances, and you are expecting that the project will cost more than the planned budget. The total estimation at the end of the project is the estimate at completion. It is the estimation of how we are expecting our project to cost us at the end of the project. If it becomes obvious that the budget at completion is no longer viable, the project manager should consider the forecasted estimate at completion. Now, forecasting the estimate at completion involves making projections of conditions and events in the project's future based on current performance information and other knowledge available at the time of the forecast. Forecasts are generated, updated, and reissued based on the work performance data that are provided to this process from the execution processes. The work performance information covers the project's past performance and any information that could impact the project in the future. Estimate at completion are typically based on the actual costs incurred for work completed plus an estimate to complete the remaining work. So the estimate to complete, or the ETC, represents a forecast of the value of money or the amount of money you are expecting to spend in order to finish the remaining part of the project. So the estimate to complete from today, how much are you going to spend or you are expecting to spend on the project to finish the remaining work. It is incumbent on the project team to predict what it may encounter to perform the estimate to complete based on its experience to date. Earned value analysis works well in conjunction with manual forecasts of the required estimate at completion costs. The most common budget at completion forecasting approach is a manual bottom-up summation by the project manager and the support of the project team. The project manager's bottom-up estimate at completion method builds upon the actual costs and experience incurred for the work completed, and it requires a new estimate to complete the remaining project work, and the formula will be is that the estimate at completion equals what we actually spent to date plus the bottom-up estimate to complete based on the team input what we are going to spend to finish the remaining work on the project. Now, in addition to the manual formula, which is estimate at completion equals the actual cost plus bottom-up estimate to complete, we have another 3 common methods to determine the estimate at completion. Which method should you select? That depends on the scenario and the assumptions made in the scenario, either in real life scenario or in exam question. The first method is the estimate at completion forecast for estimate to complete work performed at the budgeted rate. This estimate at completion method accepts the actual project performance to date, whether it is favorable or not, as represented by the actual costs, and predicts that all future estimate to complete work will be accomplished at the budgeted rate. This is the main assumption. In order to use this formula, which is estimate at completion equals the actual cost plus budget at completion minus the earned value. This is the first method. To use this method, the assumption is that all future estimate to complete work will be completed at the budgeted rate. When actual performance is unfavorable, the assumption that future performance will improve should be accepted only when supported by the project risk analysis. So if you were given a question with the assumption that the remaining work on the project will be executed at the budgeted rate, you will use this formula. The second formula, estimate at completion forecast for estimate to complete work performed at the present cost performance index. This is the most common one. This method assumes that what the project has experienced to date can be expected to continue in the future. The estimate to complete work is assumed to be performed at the same cumulative cost performance index, and the formula will be estimate at completion equals the budget at completion divided by the cost performance index. And the last formula, estimate at completion forecast for estimate to complete work considering both the schedule performance index and cost performance index factors. In this forecast, the estimate to complete work will be performed at an efficiency rate that considers both the cost and schedule performance indices. So in order to use this formula, we will consider the schedule and cost performance indices. This method is most useful when the project schedule is a factor impacting the estimate to complete effort. Variations of this method weight the CPI and SPI at different values according to the project manager's judgment, and usually the formula will be the actual cost plus the budget at completion minus the earned value divided by the CPI multiplied by the SPI. These are the three formulas in addition to the manual formula, which is actual cost plus bottom-up estimate to complete. Another technique that can be used in this process is the reserve analysis. During cost control, reserve analysis is used to monitor the status of contingency and management reserves for the project to determine if these reserves are still needed or if additional reserves need to be requested. So while you are executing your project and monitoring the project cost, you need to keep an eye on the reserves associated for the project to check if the remaining reserves are enough or they are adequate for the risks remaining on the project. As work on the project progresses, these reserves may be used as planned to cover the cost of risk responses or other contingencies. Conversely, when opportunities are captured and resulting in cost savings, funds may be added to the contingency amount or taken from the project as margin or profit. So you will conduct this data analysis technique to determine if the remaining reserves are enough for the remaining work on the project or not. If the identified risks do not occur, the unused contingency reserves may be removed from the project budget to free up resources for other projects or operations. So if a risk was outdated or a risk will not occur anymore, then the reserves associated with this risk should be returned back to the organization. Additional risk analysis during the project may reveal a need to request that additional reserves be added to the project budget. The last tool of this process is the to complete performance index, and you should expect at least one question in the exam about this tool. It's a measure of the cost performance that is required to be achieved with the remaining resources in order to meet a specified management goal, expressed as the ratio of the cost to finish the outstanding work to the remaining budget. So it's the ratio of the cost to finish the outstanding work to the remaining budget on the project. TCPI is the calculated cost performance index that is achieved on the remaining work to meet a specified management goal, such as the budget at completion or the estimate at completion. If it becomes obvious that the budget at completion is no longer viable, it's not viable anymore, the project manager should consider the forecasted estimate at completion instead of the budget at completion. Once approved, the estimate at completion may replace the budget at completion in the TCPI calculation. The formula is budget at completion minus earned value divided by the budget at completion minus the actual cost. If the budget at completion is not viable anymore, we can use the estimate at completion instead of the budget at completion in this formula. The TCPI, conceptually displayed in figure below, the equation for the TCPI is shown on the lower left as the work remaining, defined as the budget at completion minus the earned value, this is the work remaining, divided by the funds remaining, which is the budget at completion minus the actual cost, or the estimate at completion minus the actual cost. Now for the TCPI index, if it is more than 1, that is bad for the project, and if it's less than 1, it means the project is progressing well. Now some of the examples for the earned value analysis before we move to the outputs of this process. A project with earned value of $5,500, actual cost of $5,000, planned value of $7,000, and total project budget of $10,000. Assuming the original estimate was flawed, it's not viable, and your team has given a new estimate of completing the remaining work of $12,000, what is the project variance at completion? This is an important question. Now, based on the assumption given in the question, you need to determine which one of the 4 formulas you should use, and the formula or the assumption is made clearly here that the original estimate is not viable anymore. It was flawed, and your team has given a new estimate to complete, bottom-up estimate to complete, which is $12,000. So simply the estimate at completion equals the actual cost plus the estimate to complete. So the variance at completion formula equals the budget at completion minus the estimate at completion. Budget at completion was given in the question. It's $10,000, the project budget. It is the budget at completion. Estimate at completion was not given, but based on the assumption made, it's the AC plus ETC. AC is given, it is $5,000, and ETC was given by the team, it's $12,000. So the estimate at completion is $17,000. The variance at completion equals the budget at completion minus the estimate at completion. By applying the formula, you are forecasting that you will spend $7,000 more than what was planned by the end of the project. This is the negative variance. Another example, assuming that the current variances are atypical and remaining work will be completed using original estimates. Your project team prepared a forecast report for you with the following data. The variance at completion is minus $70. The actual cost is $350, and the total project budget is $500. The report does not include the earned value. Using the information given in the question, what is the earned value? So we need to apply a reverse formula. We will move backward in order to determine the earned value. Now, by applying the variance at completion formula, the variance at completion is given, and the project budget is given as well. So for this formula, we have the VAC and we have the BAC. So minus 70 equals 500 minus the estimate at completion. So the estimate at completion equals $570. Now the assumption made in the question is that the current variances are atypical and remaining work will be completed using original estimates. We will use the formula estimate at completion equals the actual cost plus budget at completion minus the earned value. Estimate at completion, we just find out what is the estimate at completion. Actual cost is given, budget at completion is given, so we can determine the earned value from this formula. Plugging in the numbers, the earned value is $280. Now the outputs of this process, now don't worry about more examples about the earned value analysis. Go to the focus on math section, you will find a lot of examples regarding this technique. Now the outputs of the control costs process, starting with updates to the project documents. Any new assumptions regarding the cost performance might be updated to the assumption log. Cost performance may indicate the need to revisit the original basis of estimates, and there might be updates to reflect the actual cost efficiency to the cost estimates. If there are any lessons learned about controlling costs and applying the earned value analysis, this can be reflected in the lessons learned register, and the risk register might be updated if the cost variances have crossed or are likely to cross the cost threshold. This is a risk which you need to add to the risk register. Project management plan updates. Some of the components of the project management plan that might be updated are the cost management plan. Changes to this plan, such as changes to thresholds or levels of accuracy required in managing the project's cost, are incorporated in response to feedback from relevant stakeholders. The cost baseline might be updated in response to approved changes in scope, resources, or cost estimates, and the performance measurement baseline might be updated for the same purpose. Work performance data was an input to this process. It was analyzed as an outcome. You will have the work performance information, which includes information on how the project work is performing compared to the cost baseline. Variances in the work performed and the cost of the work are evaluated at the work package level and control account level. Such information in this work performance information and reports will include information about the cost variance, cost performance index, schedule variance, schedule performance index, and the forecasts like the estimate at completion, variance at completion, and to complete performance index. The cost forecasts are outputs of this process. either a calculated estimate at completion value or a bottom-up estimate at completion value. It should be documented in the cost forecast that is part of the project documents and communicated to relevant stakeholders. The last output will be change requests. The majority of the monitoring and controlling processes will produce change requests as outputs. Analysis of project performance may result in a change request to the cost and schedule baselines or other components of the project management plan.